Good morning, Massimo. Morning, everybody.
Morning, morning to
So maybe good afternoon for the ones that are in the Asian areas. And thank you for coming again to this new GMI webinar. And today we are talking about re-application for relays, standard relays, relay with the line and load monitoring. Host details. Today we are here, Massimo and I. So Massimo Pagani is our product manager, GEM International, has a very long experience in product support and also electronic say development and so on. More than 20 years experience in the field of repair and development of devices, console electronic, and also now with the GMI. Myself, Andras Prod, working in GMI since 2015. I've experience in automation, process safety, and now I'm working hazardous application and still related also. Before talking about the topic of today, we would like to give you a short overview about GMI. So the company is say known for design and engineer a complete range of products in intrinsically safe application and still rated. We are supplying main DCS companies for DCS application and SD, fire and gas, and so on. Main industry like oil and gas, chemical, petrochemical, that's our experience, and mining, food, where there are critical applications. GMI is there. We have a 40 experience, born in 1993, but our former name was Icon Instruments. And we produce completely in our facility in Milan, but we have a global presence in 5 continents. Go to the next one. Yeah. Oh, sorry. Sorry for this trouble. Okay. Product in our portfolio are intrinsically safe barriers, safety relays, isolators related to safety application, power supplies, multiplexer, termination board for DCS applications and safety places, hard multiplexer, short protections, indicators, and also a nice manual book. We have, you see the bullet down there. It's not a product, but is our manual for safety applications. And it's like our products because that is the 4th edition. We printed out more than 25,000 copies all over the years, and we sent to all our customers free of charge. If later on you want to get a copy, just send us an email. We will arrange for sending a copy to you. And our goals, of course, is we develop completely new product, new solution continuously. Our product have been certified from different agencies and accreditation body, functional safety management, systematic capabilities, and so on. Invest more than 10% of our turnover in R&D, and we provide also 5 years warranty for all products in our basket. As we said, we produce in Italy. We have a complete traceability, full testing, and we assure the best quality for our products. Some numbers about the company. So 8 subsidiaries, 78 distributors, 200 people all over the world, and a lot of applications. Installation. That's our, say, just to give you an idea about our market. So we sell to the system vendors, to the such IBB, HONEYWELL, Yokogawa, Emerson, to also to the APC. And of course, we have been approved from different end users. But we sell also the product to the OEMs, special companies that produce some application for mainly for oil and gas markets, as you can see over there. Now we go to the topic. I don't want to take your time too much. If you have any questions, you just chat is disabled. Just push on Q&A button over there, and you just send us an inquiry, and then maybe we try to answer you during the presentation. But first of all, we wanted to say to share a poll with you. So if you can answer to this poll quickly, we give you maximum 1 minute, please. Maybe we can share also these results to you, so you know what the main customers asking for. Okay, I can stop now, and I can share results with you. So most of you use standard relays, and also the next part use both smart and standard relays, and just 2% the just smart relays. Okay, so we go now to the presentation. I leave Massimo, so you can start now, Massimo, with describing what, how is the presentation is realized and organized.
Thank you, Andrea, for your introduction, and good morning to everyone. We start with our presentation. The scope of today's presentation is to specifically present smart relays and their application fields, based on the experience that GM International has built in your story. What are the specific points of today? The first point of today's presentation: what are smart relays, and what are the specific model of GM International portfolio. After that, it's important to understand why choose a smart relay, and finally, where smart relays are used and what are the typical applications. In this specific case, we will examine application as normally energized solenoid valves, strobes, beacons for fire and gas application, dual tone sounders for fire and gas application, high availability double coil solenoid valves, and single phase load interruption solenoid valve. And after, we will see our conclusion. Next slide, Andrea. Well, what is a smart relay? The smart relay is a relay that guarantees a specific safety function, like a safety relay, but in addition, it has the ability to perform field diagnostic, both for the line and load. Smart relay combine the basic safety relay functionality with a full line and load diagnostic. But what are the smart relay in the GM International portfolio? Over the years, GM International has developed a great experience in the specific sector of smart relay. And today we have a wide range of relays with complete line and load monitoring. In particular, the 5096S and the 5294S, with the relative models that allow us to reverse the content functionality. The 5097S and the 5295S can cover almost all of the typical application on this device. The main difference between the models, D59S, 5294S, and D597 and D5295S is the arrangement of the contact. In the 5294S, the normally open contacts are arranged in a 2-for-2 matrix. In the D5097S and D5295S has the same matrix as the previous model, but the normally open, normally closed contact are replaced by normally closed contact. As it will be shown later, each contact arrangement is suitable for specific application. Specifically, we analyzed the two smart relay models with the most complete and fully programmable diagnostic circuits. Let's analyze the operation of the D5294S. D5294S is suitable for both normally energized and normally de-energized load. When used with the normally energized load under normal condition, the contacts are closed. They open on demand to bring the load to its safe state, load off. For example, the valve opens. Next slide, Andrea. The contact series redundancy makes the D5294S robust to a single relay fault. In other words, even in presence of a single relay fault, welded contact, for example, the 5294S is still able to satisfy the safety function. For example, to open the load on demand. In addition, thanks to the contact matrix, D5294X exhibits high availability. If a contact opens by accident, the parallel contact redundancy allows the module to continue supplying the load. The loop is still under service. Next slide, Andrea. Okay. When used with a normally de-energized load, under normal condition, the contacts are open. Andrea, the next slide, please. Okay, thank you. Okay, when used with a normally de-energized or under normal condition, the contacts are open. They close on demand to bring the load to its safe state. In this case, load on. For example, the beacon lights up. Even in this case, the 5294S is able to maintain high availability. In fact, single fault relay is not sufficient for a dangerous failure. Next slide. Specifically, we analyzed the two smart relay models with the most complete and fully programmable diagnostic circuit. Next slide, Andrea. Okay, thank you. Two different safety functions coexist inside the smart relay. The first one, and also the main function, consists in the input to output or coil to contact activation deactivation. This is the typical function of a safety relay, which upon request is able to drive a load applied to it in a safe state. The second one is the diagnostic functionality. It provides full measure voltage, current, impedance, and earth leakage of the load through Modbus, and it can activate or deactivate through faulty dry contacts. The main function is certified seal-free, while the diagnostic is certified seal-2. Let's analyze the diagnostic section. Andrea, please, the next slide. Okay. Checking what this functionality allows to monitoring. This relay allows us to monitor the line and the load, both with the load off and load on. When the load is activated, the D5294 is able to monitor continuously the voltage applied to the load, the current flowing through the load, and the internal coil's integrity. In case of when the load is deactivated, the D5294S is able to monitor continuously the power supply voltage, the load resistance, and the leakage from the load to the ground. How and what are the ways in which a smart relays can communicate with the security system? Smart relay can report the field status to the system in several ways. First, the two fault contacts can be acquired by a system digital input port. Secondly, if the system digital output port driving the smart relay support pulse testing, the fault in the field can even be mirrored directly to the DO without the need of an additional DE card. This feature will be investigated in more details later. Thirdly, complete diagnostic information can be retrieved through Modbus, multi-drop RS485 protocol, if a Modbus master is available on the system side. And the last, the fault on bus can also be acquired by a system digital input port. The fault on bus is normally used when a cumulative report is required. Okay, what are the reasons that make us prefer a smart relay to a regular safety relay? Why going for a smart relay? Nowadays, a full diagnostic is typically required along the full loop. However, many widespread systems do not support diagnostic inside their DO cards. Smart relay make diagnostic available to systems that do not support it. Many modern systems do support DO diagnostics. However, in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliamps at 24 volt DC. And then when the load, the valve, beacon, sounder, etc. require more than 24 volt and or more than 500 milliamp, relays are necessary. Yet when using standard relays, the DO diagnostic pulse testing dies and the relay coils and cannot reach the load in the field. As opposite to that, smart relays can go beyond the typical voltage current system limitation while keeping the full load diagnostics. Even if a modern system can perform load diagnostic, their capabilities may be limited. For instance, her leakage monitor may not be supported, or extreme load, for example, beacons, may always be reported as an open circuit to the system. Smart relays may offer a solution to extend the DO diagnostic capability. Okay, next slide, Andrea. Thank you. Smart relay may offer a solution to extend the DO diagnostic capability. In the following slide, we briefly see the model and diagnostic capability of GM International Relay seen so far. And the maximum steps, we can see the D5294X with the Modbus and the configurable threshold. Next slide, Andrea. Okay. Fault mirror to the PLC. This function allows us to transmit information relating to the field fault directly to the supervised DO card of a PLC, both in the off state through the pulse test system and in the on state by reading the static return of current. The DO card of a PLC system can detect the information relating to the field fault. This system, through an upward impedance variation of the relay input circuit, allow us to supervise the DO to see the fault in the field. This system allows considerable saving in the engineering cost, as it allows us not to use a dedicated D card for this purpose. Okay, Andrea, we have a poll now.
Nice. We have another poll. I think maybe it's also interesting for you. And I'm given as an answer. We already got some questions from you live, then we try to answer you. Still answering, somebody still answering. Okay, let's see, now we can stop and share result with you. So we see that fault mirroring on the OCR is the most interesting part. Indeed, we got some questions from you, from one of you especially, that asked if the additional digital input point required for fault to the PLC. Exactly. So the thing is that the fault from the relay can be acquired to the PLC in different ways. And the first, let's say, simplest solution is by the digital input. So the DO from the relays go to your digital input. So you need additional digital input, of course, for each relay. And the second one is through Modbus. If you use a specific relays with Modbus capability. And the third one is by fault mirroring on the OCAD. So in this case, is really, let's say, the most, let's say, the smartest solutions. I would say that is possible with a lot of systems, but not with all systems because of the internal design. And so maybe later on, if you're interested in that, you just send us the system you're using, and maybe we can give you some information about our experience with that specific systems. Okay, I think we answer to these questions, and we can go over with the next slides. Okay, so now we are talking about real-world application with systems. We made 5 different examples, and that may be the most practical part to you. And now we see that application can be done with different solenoid valves, normal energized solenoid valves. Can be done with straw beacons for fire gas applications. We already see something now. Dual tone sounders. Also, there are applications where sounders have dual tone, so for different information or alarm for fire gas. And also high availability double coil solenoid valves, because some valves in some critical application have double coil, and those double coil are being used for redundancy. So each single valve works with just one coil, and the second one is for to have high availability. And the last one is a single phase load interruption solenoid valves. Okay, and let's go to this real application as be done with Delta V Sys from Emerson. The application is ESD, emergency shutdown, with a solenoid valve. In this case, the application is this one. So the system is driving the output through the relays, and the solenoid valve, of course, give the feedback in case of fault to the system. That is the most, typical application for smart relays. In this case, the relay, as we said, is used because the system has some limitation either in monitoring, but most usual applications when the system is not able to give enough power for the load, so external relay have to be used. Okay, and so this is the application. This is the offline state. So I have my system digital out here, and I have my load and the relay itself that is driving the load, which is a valve in this case. And this is the power supply for the valve. See? So this is the offline situation. And the normal situation is that my system is acting on driving the load. My contact will close on the relay, and the valve will work in a standard way. That is normal situation. What happens if go to the safe state? Safe state means that I need to open. So my system digital out will open. So my relays will open, and the flow will stop into the valve. That is a safe state. Okay. So we are talking about ESD system. So let's see what happens in case of open circuit, because I'm with the relay, as we said, we can monitor the open circuit situation. So open circuit situation means that I got a fault here on my line. So my line will be open. My relay the relay in this case can detect the fault, and the fault will be reverted to the digital input system. Okay. So the system will we get know that my valve is not working properly, because I want to be in a normal energy situation. I'm not in the safe state, but for any problem can happen in the process application, my circuit will open. So I need to know why opens or if opens. And from the system point of view, I don't know that, because I'm just acting here on the relays, And the relays basically is just driving the load in the same with the same logic. This is a situation that happens by accident, and this is very good because I can get this information. I can, let's say, do my maintenance. I can have, of course, I see load open circuit, okay, and I can go to the load short circuit. So the relays can also, say, detect short circuits. So the short circuit will be, as for the open circuit, detected and reported to my digital input. This is a real application made with, I remember you with DeltaV sys from Amazon in combination with that. So that's the case. I can have also problem on my power supply. I mean power supply for the valve. Okay, so the power supply can fail if I'm situation that the power supply fails. That fault also will be reported to the system because the valve is not operating. Also, on some relays, like the most evoluted ones, can detect also internal coil fail. It means fails on one relay. So my relays is not get a fault that can happen, of course, as the other parts in the system can get a fault. But in this case, you see the metrics relays is assuring that my valve is still operating in a proper way, but I can know that there is a fault in internal coil, and I can know over digital input and over Modbus this information also. So then we have seen application with Amazon DeltaV sys. Now we can see an application we did with DCS from ABB in combination with beacons from MEDC. And the same situation, I have my system that is that know that the beacon is not operating properly. And here we try to reduce as much as possible the information. And through the strong beacons, we can detect the faults like power supply, open short circuit, earth leakage, internal coil fault. Those are the failures that I can detect. I remember this to you, this is application made with the DCS from ABB, in combination with the beacon from MEDC. The next one is application did with Foxbird DCS, MEDC sounders in this case. And here also I have the application where the sounders can report the fault to the system. This is the real, say, we study a lot, as you can understand from these slides, because it is a dual tone sounder. So it's driven by two relays, and the two relays can, say, driven the different sounds of the sounder itself. Also in this case, we can detect the fault detected in this case of the power supply fault, open short circuit, and also internal coil fault, just for the 5294S, which is the most evoluted relays. The next application is has been done with Yokohama ProSafe RS, so the safety PLCs. We are talking about double coil valve, And the double coil is quite interesting because, as we said, the double coil assure it and assure it the high availability of your valve. Okay, so it's this is the application, and the double coil is by using these relays, only these relays, and I can detect if one coil of the valve is failing or will fail, and in this case, the valve is still working because the double coil assure that I have a HFT, hardware fault tolerance 1 on my valve. So, but I know that one coil failed, and I can get this information over my system and maybe replace the valve or repair it or whatever, but without stop my system. So this is a very important information because I can detect that there is a difference on my load. The relays are active too, and I can really detect the failure. Other failure, of course, just internal coil for the relays, open short circuit, and the power supply is fault as well. Okay, so the last application with the Honeywell C100 DCS with a solenoid valve, and as for the others, the relays used here both for monitoring the load and for increasing also the power to the system, because the DCS is not able to drive the load. This is an, let's say, very good application because this is a single phase load interruption. So you can interrupt and you can use less wire to the process because you have just one wire to the process, not two. And in case of long distance and in case of low power, as it is in this case, I can use just one wire. Detectable fault, of course, power supplies fault, open short circuit, internal coil fault, and also Modbus interface that assure you that you can detect all the fault from different loads through just one Modbus interface on your system. This is very well appreciated because wiring, Modbus offers a good advantage in terms of wiring, in terms of digital input, because you don't need a digital input for detecting the faults. And it's very simple. If you wanted to add more relays, just add the relays, and the Modbus communication is already pre-configured. You don't need to use other things. Okay, and I'll leave you, Massimo, to the software because that is also maybe interesting part for you. What is you can do, because some of our relays are configurable, so the limit can be set. Massimo, you can continue if you like it.
Okay, thank you. And as you can say, the 5294S and the 5295S can be also configured when the parameters to be monitored are really specific and the alarm trigger is not achievable with standard monitor relay. We can see the software interface for our relay, where we can set all parameters. First of all, the voltage of power supply limits for in case of when the relay is in on state, we can set the current limit, or when the relay is in off state, we can set the impedance of the loads. Another parameter is the isolation resistor. This means and to allow us to detect eventual dispersion of current in respect to the Earth. And then we can also detectable the coil integrity and the driver status, and monitoring and data logging functionality are available too.
Yeah, just a few words about why you have to use a configurable relays instead of the standard ones, because there are different loads, different say safety loads, especially we're talking, I think, Massimo, sounders, beacon, and those kind of things, lights that are really have different load values, impedance difference, and only by using configurable relays you can set the right threshold. Otherwise, if you're using maybe standard relays, you be always in safe situation, always in the fail situation. So, and you cannot discriminate the real failure for the load. And
yes,
just this one that give you possibility to set a threshold, limit where the relay is alerting the system. Okay. In this case, you can get this, let's say, flexibility.
Yes, for example, we have the possibility to set the range for the load resistance up from 5 ohms up to 50 kilo ohms, for example. And for the power supply voltage load, we have the possibility to set from a minimum of 10 volt up to a maximum of 230 volt. And again, we can set the hysteresis parameters like high and low, and we have the possibility to decide the fault that we have to see. Okay.
And also the software give you a possibility to monitor the relays and make some data logins that is useful functionalities. Like we can see in the next slides, Massimo.
Yes. Through the configuration software, it is also possible to read in real time the value of voltage, current, and load impedance, both for load off and load on. First example is what we see in the slide, where an impedance solenoid valve of about 100 ohm is monitored together with its current. In case there was a problem with one of the internal relays, and the software immediately reports it, keeping the load energized, and signal the fault towards the PLC through the mirroring functionality, or the digital input content, or via Modbus. Next slide. Okay, in large industrial compounds, for example, refineries, etc., double coil valves are normally controlled by a single digital output driver. In this context, the D5294S is again an optimal solution because it can detect the opening of the single valve coil, hence providing predictive diagnostics for prompt maintenance while keeping high availability. Here we have the example of monitoring and fire and gas system, where a partial short circuit affects the winding of the solenoid. The relay that monitors the solenoid impedance detects an anomalous value below the programmed acceptable threshold and signal the fault at the PLC.
So here you can set exactly what is the resistance value that where is necessary to get the alarm. And you can discriminate exactly, that is the specific point.
Yes, the software interface is not a measure instrument, but have a particular accuracy in the measure.
Okay, I have, Massimo, we have two questions from participants. I think it's better to answer now. So, one attendee asked, in this example, line monitoring is between a relay and solenoid valve only. Maybe it's referring to another. There is no line monitoring between relay and the PLC. So what we can say from this point of view?
Yes, the relay can have the possibility to mirror the fault in the field towards the PLC, or have the possibility to the relay is compatible with the pulse test function of the PLC for the monitoring of its input side.
Exactly. So basically, the pulse testing is already a monitoring system for the PLCs, and is, of course, that is the important point. Our relays, the relays are compatible with that pulse testing. So in case of fault, of course, that will be case of fault communication between the relay and the system that will be detected.
Yes, this type of relay can give us to have the possibility to detect a fault from the field up to the PLC.
Okay, another question. Can these relays be used in intrinsic safety application? Are they certified for use in hazardous environment? The answer is
no, it's not for intrinsically safe application.
Say not intrinsically safe application. We're not talking. They are certified for use in zone 2,
yes,
hazardous areas. But we cannot say that it's for intrinsically safe application, Massimo, because we are talking about 5 amps or 10 amps currents. No? So
yes, yes, it's true.
It's a different, it's not intrinsic safety, but is of course can be used in hazardous environments.
Yes. And Andrea, we have another question.
Yeah.
What is the operating temperature range for this relay? The operating temperature range for this relay, as for all our devices, for the D5000 series is minus 40 degrees Celsius up to plus 70 degrees Celsius. This allows us, this wide range of temperature allows us to have a longer lifetime of the device, up to 20 years.
Okay, good. No more questions, so we can go to the next slides. So we have talked about what are smart relays, why choose smart relays, and the application related with. We have seen that there is very much interest from you for the mirroring functionalities. So I invite you to send us your requirements about that. So as we said, it's compatible, that functions are compatible with a lot of systems, but not all systems. So we don't want, of course, go in details now because it's would be too much complicated. If you have any questions, just please send us an inquiry. Yes, with conclusion, Massimo, you can go to the conclusion now.
Yes, for the conclusion, we summarize the main common features that have been discussed all through this presentation. And our smart relay has a seal-free to certified coil to contact function. The D5294 is suitable for both normally energized and normally de-energized application. Note that the contacts are normally open if the input to output relation is direct. When the drive is on, the load is on, and the other way around. And the D5295S is suitable for both normally energized and normally de-energized application. And note that the contacts are normally closed if the input-output relation is inverted. When the driver is on, the load is off, and the other way around. And we have the diagnostic load and line functionality even in our models D5090SS and D5097S with line and load short circuit possibility to detect and load supply present. Even also Modbus RTU RS485 supported only on our model D5294S and D5295S. And all our relays are compatible with the OCR line monitoring pulse test and with the function of fault mirroring to the OCR.
Yes, one thing, maybe more that has been asked by attendees, why you have a coil-to-coil CL3 and the NOS is only CL2. It's maybe because that is a really software, the NOS is a really software-based, and it's not really, let's say, certificate. We're not able to certify for CL3, but is only CL2 and is not interfering with the main safety function, which is CL3. So is within the unit, within the hardware of the device, but not interfering with the safety function. That's why it's possible to, let's say, keep the CL3 certification for the relays. And so, we're almost done. There is another question. What is the useful life of the GMI relays? Lifetime is 20 years.
Yes.
It means that we are talking about relay CL3 relays, 20 years. The T-proof test is, of course, is lower. It can be 2, 3, 4 years, depending. But if you're using CL3 relays in a CL2 application, you can extend this T-proof time. In some cases, you can reach this the T-proof time equal to the lifetime for CO2 application. It means 20 years. Okay, answer. Let's wait if there are more questions from the attendees, but I don't see any more things. Massimo, I think we can go to the last poll. So you can, we ask you to rate this webinar. It's a very, very simple question to you. So thank you very much if you can rate it. In the meantime, if you have any questions, just write us. Thank you very much for your answer. We are really satisfied about yours. Okay, thank you very much. I don't share with you, but this poll, because it's of course, but you were satisfied, so we are pleased about that. Contact details, Massimo and I. So here you can see our details. You can write us for more questions if you want to have more details. We will be pleased to send you. And of course, this is a presentation will be not shared, but the video will be shared on our YouTube channel. So you will see this video and others from previous webinars. I invite you also to go to the GMI calendar for more webinars. Maybe if you want to participate to this one or the others, maybe to this related to the safety relays, why it's important to use safety relays and so on, or maybe say physical safe barriers or things, maybe topics related to the functional safety is also very important, are also very important webinars. So if you don't have further questions, we can leave you now, and thank you for participating.
Thank you very much for your participation.
Thank you again. We will see you soon. Thank you. Bye.
Thank you. Bye-bye.